JEE Main 2026, 2nd April Shift 2, Physics Section A, Question 38. Let's draw the circuit. We have a 100-volt battery connected in series with a 200-ohm resistor. After the resistor, the circuit splits into two parallel branches, a 400-ohm resistor on one side and a bulb rated at 200 volts, 100 watts on the other. Both branches reconnect and go back to the battery. Watch the current flow through the circuit. The question reads, two resistors of 200 ohm and 400 ohm are connected in series with a battery of 100 volts. A bulb rated at 200 volts, 100 watts, is connected across the 400 ohm resistance. The potential drop across the bulb is blank volts. The options are A, 25, B, 50, C, 66.6, and D, 100. The key concept here is series parallel resistance. First, we must find the bulb's resistance from its rating. Then, the bulb is in parallel with the 400 ohm resistor, so we calculate the equivalent parallel resistance. This parallel combination is in series with the 200 ohm resistor. The total resistance gives us the total current from the battery. Finally, the voltage across the parallel combination equals the current times the equivalent parallel resistance. This is also the voltage across the bulb. Step 1. First, find the bulb's resistance. Using the formula R equals V squared over P, we get 200 squared over 100, which is 400 ohms. Now the bulb, with 400 ohm resistance, is in parallel with the 400 ohm resistor. The equivalent parallel resistance is 400 times 400 divided by 400 plus 400. Computing this gives us 200 ohms. Step 2. The 200 ohm resistor is in series with the 200 ohm equivalent parallel resistance. So the total circuit resistance is 200 plus 200, which equals 400 ohms. The total current from the battery is V over R total, which is 100 divided by 400, giving us 0.25 amperes. Step 3. The voltage across the parallel combination, which is the same as the voltage across the bulb, equals the current times the equivalent parallel resistance. That is 0.25 times 200, which gives us 50 volts. Notice how the 100 volts from the battery splits equally, 50 volts across the 200 ohm series resistor and 50 volts across the parallel combination containing the bulb. The potential drop across the bulb is 50 volts. The correct answer is option B. Options A, C, and D are incorrect. Here are some exam tips for circuit problems. First, always calculate the bulb's resistance from its power rating using R equals V squared over P. Second, remember the parallel resistance formula. And most importantly, when two equal resistances are in parallel, the equivalent is simply half of one resistance. This shortcut can